Hello everyone, welcome back to a new 4Skids TV video. My name is Matthew David, and in this video I'm going to be demonstrating how to detect and bypass basic antivirus signatures in 3 different languages: PowerShell, CSharp, and C++. Let's get into it. For this video, I'm pretty much going to only focus on manual detection and modification using trial and error. That's pretty much how I, most of the time, bypass these signatures. But there are a lot of automated tools that you can use to assist in the process, which I will reference a few in the video. But this is just going to be a basic overview using some simple sample code that shows you the general process of how to detect these signatures and modify your code to bypass them using simple trial and error methods. So the first language I'm going to be demonstrating this process in is in PowerShell. I'm splitting it up language by language as there's a little bit of a difference, especially when modifying the code for each language. So deciding to do PowerShell first. Right now you can see I'm looking at my desktop. I have real-time protection and cloud deliver protection turned on. And I also have the PowerShell ISE window open and ready to go. So the sample code that we're going to be using to show this process is the AMSI scan buffer AMSI bypass by Ross Mouse. And I figured this would be a good example because it is a very short piece of code and it's a very useful piece of code. So by showing this, we'll be able to show the process and also at the end of it have something very useful that we could use in real world environments to execute programs without getting detected by antivirus. So I'm going to copy the code. I'm going to go to our PowerShell ISE window, paste it in there, and now we can just try running it to see that we do indeed get an error saying that the script contains malicious content and has been blocked by your antivirus software. In addition, if we tried to, for example, load and execute a tool like Rubius in memory, you can see that also gets detected, showing that our AMSI bypass was not able to successfully execute. So now we can begin the process of trying to figure out what AMSI is detecting our AMSI bypass on, and we can try to then modify our code so that it can no longer detect it. So the main way that I find signatures by the trial and error process is by removing large pieces of code from the program and then slowly re-adding them to see at what point the antivirus starts to pick up the program again. And that way I'm able to actually narrow down, okay, this part of the code is not getting flagged. And when I add, certain parts of the code, it does get flagged. So at that point, I'm able to determine, okay, this particular line of code or this particular few lines of code is what's triggering the antivirus. So that's what I have to modify in order to bypass the signature. So the first thing I'm going to do for our sample code is remove every single line other than the first one, which of course is a declaration of the Win API functions that we need in order to use our AMSI bypass. It could be possible that this is the signature that the antivirus is using in order to detect the program. So if we just run this by itself and it doesn't get detected, that'll help us determine that, okay, no, it's probably not this string. So if I hit the run button, you can see the code was able to run and we did not get an error from AMSI showing that this is probably not the signature. So like I said before, I'm going to slowly add the rest of the code back. So I'm going to paste it in, and now let's just try leaving the next line in, which is the add type function that's loading the variable that we had previously declared. So if we remove everything else other than that and run our code, you can see that also worked. So like I said, we're going to again slowly add more code back to the program. Next is our load library call that loads AMSI into memory. So let's see if we run that. That also works without getting detected. So we made it pretty far so far, so let's keep going. Now we have get proc address. So we're going to leave that in, remove everything else, run that. That works. And I'm doing it line by line as it's a pretty small program, so it won't take much time. If it's a bigger program, you'd probably be doing this in bigger chunks. But we're doing pretty good so far, so let's keep going. We have our P variable. That also works. We have our virtual protect call. That also seems to work. we have our patch of the bytes that we want to patch AMSI with. That seems to work too. So now we can just add the last line that we have, which is the call to copy that actually copies the bytes to the AMSI scan buffer location. So let's see if that is indeed what's triggering it. And we can see we finally get that AMSI error showing that the call to the copy function does seem to be the signature that AMSI is using to detect this piece of PowerShell code. One thing I'd like to explain before moving on is that, yes, the copy call that we found earlier does seem to be the signature that's making AMSI flag this file as malicious. However, it by itself may not be detected as malicious, but rather only when it's combined with other pieces of code that are found in our program. So for example, if I open a PowerShell terminal and I paste in this line that we had earlier, it tries to run, but doesn't work because it doesn't have the correct variables in there. But it shows, because it didn't get detected by AMSI, that this line of code in and of itself is not flagged as malicious, but only flagged as malicious when it's combined with the code that's found in our AMSI bypass. Other pieces of strings or code, like AMSI scan buffer, you can see that that gets detected by the antivirus, because anything that contains AMSI scan buffer, even if it's just typed directly into the console with no other code, is detected as malicious. So there doesn't need to be any other code in combined with that string for the antivirus to flag it as a signature. So I just think it's kind of important to realize that not every signature is necessarily flagged as malicious in and of itself, but oftentimes it needs to be combined with other code that the antivirus, when looking at the entire thing, says, okay, this combined with this equals a malicious file. Okay, so now that I've explained how signatures work a little bit more, we're going to go back to our program and try to obfuscate the line of code that we detected as a signature to see if we can get our program to run without being detected by AMSI. Now, because we're using PowerShell, we're going to be able to do something that we can't really do in compiled languages like C# and C++, and that's dynamically invoke code that comes from obfuscated strings. So to demonstrate what I mean by this, I'm going to be taking the line of code that we detected was the signature for this program, and I'm going to split it up into 3 different strings, which I then add together and execute via PowerShell's invoke expression function. So to start off, I'm going to create our first string, which will be string 1, and that's just going to equal the first part of the line that was getting detected. So I'm going to cut it off here where our function call begins, and I'm then going to create the second string, which will contain the first part of our function call. And then I'm going to create our final third string, and then add them all together and use IEX, which is invoke expression, to execute them the same way that our code would execute if it wasn't split up as 3 strings. Okay, so we can try running this program and seeing if this worked. So luckily we were able to see that we did not get an error from AMSI, meaning that our AMSI bypass was able to run now successfully without being detected, and we successfully bypassed the signature that AMSI was using in order to flag our code. So we can demonstrate this even further by loading Rubius into memory, which now works with no issue, and then using it like so, seeing that, we're able to use Rubius so that our AMSI bypass definitely worked correctly and we were able to bypass a signature. Now you can see that mine worked on my first try, and that's because I tested everything in advance and I didn't want this video to take forever. but you're probably going to have to play around with it a little bit. It doesn't have to be super complicated. As you see, I only had to split that signature into 3 different strings, and I did not need any encryption or encoding. But you may have to split it into smaller strings or use some encoding or encryption. But you should be able to just get something that works by doing simple trial and error using the method as seen here. So the last thing I want to touch on just before ending the PowerShell segment of this video is there's a repository on GitHub called PowerShell Armory that I kind of learned a lot of this from. Here you can see he has an AMSI bypass that he obfuscated, and it's essentially doing what I just showed. It's splitting different lines of code into smaller strings, adding them all together, and then executing them using IEX. So as you can see here, he's done it into a lot smaller strings. That's probably better and more reliable to bypass AMSI. But we can take the raw version of this and just load it into memory to see if it works. And you can see that it does work. So this method is a very versatile and easy method in order to bypass signatures using PowerShell. He has a script called invoke shuffle, which will help automate this process. I won't be demonstrating it right now in this video, but I highly recommend you checking it out to maybe help automate the process and make it a bit easier for you. All right, now we're going to be beginning the second part of this video where I demonstrate how to find signatures in a C# program and how to modify your code in order to bypass them. So right now you can see I'm looking at Visual Studio 2019 and I have another AMSI bypass pasted into the editor. I'm deciding to use another AMSI bypass as it's a pretty short piece of code, but also a very useful one. This is essentially the same thing that we were looking at in PowerShell, except it's a C# version of it that will compile to a DLL file that we can then load via PowerShell and execute so that we can load whatever we want into memory without being detected by AMSI. So looking at our code, if I first just compile it as is by clicking the Build Solution button, you can see it says it's up to date because I didn't change anything. And if I open a terminal and then move the DLL file to a location that does not have an exception for it in my antivirus software, you'll see that it should get flagged by Defender. You can see Defender is now saying there's a current threat that's classified as an AMSI tamper file, which it is as it's an AMSI bypass. So we're now going to try to find out why it's detecting it, what the signature is, so that we can modify our code in order to bypass that signature. So to find the signature for our C# program, I'm pretty much going to be doing the same thing that I did with our PowerShell example, and that's removing large pieces of the program and adding them back slowly so that I can determine what gets detected and what doesn't, which will eventually help us narrow down what exactly the signature is. So if we go back to the program and first just comment out the entire function that does the actual patching of AMSI, like so, and then recompile our program, go back to our terminal, and then copy it to our public directory, we can see that Defender did not flag it and it's still there, so it was not detected by the antivirus. So we know that this portion of the code that defines our WinAPI functions are not the signature that is making it get detected. So we can then go back and uncomment our main function call, and we can start commenting out things in it. So for example, we're going to leave the first 2 lines there and comment out everything below it, recompile our program, do the same thing by copying it into a directory that isn't excluded from the antivirus, and we can see that also did not get detected. So same thing, go back to our program. This time we'll add 2 more lines of code back, comment out everything below that, and recompile. Go back to our terminal, That didn't get detected either. So you can see how the process works. I'm going to speed it up a little bit now by just leaving out our last line, or rather our last two lines. Building, going back to our terminal, copying it, still doesn't get detected. So we know it's something here that's triggering the signature for the antivirus. So it's probably not this console read line. So we'll just try commenting out the Marshall copy, building our solution, copying it to our directory. Does not get detected. So we pretty much confirmed that it's the marshall.copy function call. That's what's getting our file detected, and that's the signature. So we'll re-add it, build, and then copy it one last time and confirm that we did get a detection from Defender, and it's detecting it again as the AMZ tamper. So now that we have our signature and we do know it's the Marshall copy call, the same thing it kind of was for our PowerShell example, we're going to have to find a way that we can change our program so that the antivirus is no longer able to pick up on its signature. Unfortunately, since this is a compiled language, we're not going to be able to do what we did with PowerShell in splitting this up into multi-different strings and then adding them all together and invoking them on runtime, as you can't really do that with compiled languages. So we're going to have to figure out another way that we can change this code so that it looks different, but still functions the same way. And that's the main premise of, bypassing all these signatures, is making the code functionally pretty much the same, but still making it look different enough so that the antivirus can't detect its signature anymore. So to do that, we're going to simply take our function call and put it in a user-defined function so that it's no longer being directly called after all these other lines of code, and it changes the execution flow of the program a bit. So if I go up here and define a new function, I'm going to use a private static void, and I'm going to name it copy, as that's what it's going to be doing. I'm going to give it the arguments it needs, that the Marshall copy function needs in order to function. So we're going to make a byte array called patch. We're going to make a integer pointer called address. And we're going to open it up and then just paste in our Marshall copy call with the same arguments that it had earlier. So now that we've created the user-defined function, we can simply just call it on the same place that the Marshall copy used to exist. So if we do copy and then give it the parameters it needs the patch parameter, and it also needs the address parameter. We pretty much changed our code, at least how it looks superficially, even though it'll function exactly the same way. So we can now try building our newly modified code. We can go to our terminal and we can copy it into our directory that does not have an exclusion. And you can see that looked like it worked without any issue. So I can now try using our DLL, using add type, give it the path flag, and then point it to our users public directory, add our DLL, and you can see that that worked with no issue. And supposedly now we can use our function by using some reflection calls. So we got to give it the add AMZ BP namespace, give it the program class, give it our function name, which is cha-ching, and we can then just execute this, which executes the function that we see here. You can see it says patch applied, which means our AMZ bypass is applied. And now we can download and invoke a program that would get detected, like Rubius. And we can see that all of that worked without any detections by the antivirus. So that pretty much concludes the C# portion of the video. I hope you understood what we did in order to bypass the antivirus signature. It's not very complicated. We just kind of changed the code up a little bit, even though it's functionally the same, just to make it look a little different. It's pretty simple. I was trying to keep it simple so that this video is not too long, but just so that you can look at something that may be a little bit more difficult and does a little bit more stuff. Right here you can see I have a program of mine called Reflective Loader that I implemented some of these techniques in. It's essentially just a program that will pack a C# executable, create a stub for it, and load it when executed after running an AMZ and ETW bypass. So right here you can see the stub. This part of the stub pretty much looks almost exactly like the code we were just looking at to patch AMZ, because that's what it does. We have the same copy function that's used to help break the code up and make it look a little bit different so that the signature doesn't get detected. We have another function called patcher, which does the same thing, just changes the code to make it a little different so that the signature can no longer be detected. We have some code to decrypt it. And then we also have some code here that decrypts some junk data before patching AMZ and ETW, which helps avoid the signatures as well, as that's another way that you can change how the program functions or the execution flow of the program. So if you do a certain task before another task, that could help bypass the signature, as you're adding more code to the program that can kind of confuse the antivirus into thinking, you know, the program does something different, even though it contains this thing that I flag as a signature. It's not a malicious file. So in addition to that, you can also see that I'm base64 encoding some of the strings that I used for the AMZ and ETW bypasses. This is another thing that you can do to help evade signatures, just so that you don't have those strings as is in plain text in your program. So hope you enjoyed. We're going to now move on to the C++ portion of the video. All right, everyone, welcome to the last portion of this video, where I'm going to be demonstrating how to detect signatures for a C++ file and how you can modify your code in order to bypass them. So for this demo, I've decided that I'm going to be using one of my publicly available tools called shloader, which is a shellcode loader that utilizes syswhispers. And I decided to use this because it's a great real-world example of a tool that I made and had to update because Windows Defender started to add some new signatures for parts of the tool that were causing the entire thing to get detected. So I figured, why not use it as a great real-world example, showing how we're able to find out what those signatures are and how I was able to modify my code in order to bypass them. So with all that being said, I'm going to go over to my Kali Linux virtual machine, and I've already cloned the shloader repository into a folder. And the only thing that I've done is I've modified the code to contain the old signatures that were being detected by Windows Defender, so that I can, of course, go through the process of how I found those signatures and then how I modified my code in order to bypass them. So to start off, we're just going to use the Python builder with a simple calc.bin file that will spawn a calculator once it executes. I'm giving it the tag v flag so that we get verbose output, the nr flag so that it does not randomize the syscall names, and the tag d flag so that it uses the DLL sandbox evasion method. So if I hit enter, our Python builder will write our C++ stub to a file and compile our binary. I've also modified the code so that it does not delete our C++ stub, so that we can actually look at it, modify it, and then recompile it in order to try to detect what the signature is. So if we open that up using Sublime, you can see here is our C++ stub. You know, it's not that big. It's about, let's see, 260 lines of code, so not that bad. So now we can just start going through it. Same thing we did in the previous parts of this video, remove large portions of it and slowly add them back to try to figure out, you know, what's going on here. So I'm first going to just remove, let's just remove half of the code. So I'm going to remove the everything after the getParentHandle call all the way down to our main method. So the only thing that's left is this stuff up here, the print modules function, the get loaded DLLs function, and that's pretty much it, other than the syscalls file that we're including to use syscalls. So I'm going to then go back to my terminal, and I'm going to compile the stub with main.gw. I'm going to save it as a.exe. Then I'm going to copy the a.exe file to a shared directory on my Windows host. Once copied, I can go to a terminal on my Windows host. Same thing I was doing in the last part of this video. I'm going to copy that file into a directory that does not have an exclusion in my antivirus. So I'm going to do that right now. And you can see we got an alert from Defender stating that there is a current threat, and it's classified as sysupdateGen. So that's kind of crazy. We were able to comment out half the code, and Windows Defender still detected our code, meaning that there's still a signature that exists somewhere in it. So now we can just keep modifying it, keep commenting stuff out, so we can see, you know, where the signature actually is. So we're going to now put the comment even higher. Let's comment out every single function I have in the stub for my tool. So everything is commented out other than these initial variable declarations up here and the syscalls file. So if I go back to my terminal, do the same thing, compile the code, then go over to my Windows machine and try to copy the, oh wait, I have to move over the compiled file to the Windows machine and then copy that file to a directory that isn't excluded. We can see that also looked like it got detected. And after a few seconds, we can see that it's still detecting it as a sysupdate.gen. So that's not great. We're still getting detected. So now let's comment everything out in this stub.cpp file. So we'll include these variables right here. We'll save that file, recompile. Okay, so now we're getting a function error. Don't exactly know why. Maybe it needs the main method to exist in some regard. Here, let's try commenting this part out. Going up here. And let's see if just leaving in our main method fixes that error so that we can compile it. We're of course still leaving out everything that's in the main method because we know that's not part of the signature. So if we save that and we recompile, yeah, so that works. We just needed to have our main method exist so that our compiler wouldn't completely fail. But as you can see, everything else is commented out, so it should not get picked up by the antivirus. The only thing that we're including is this syscalls file that we're using for syscalls. So if this gets flagged, then that means that the signature exists in the syscalls header that we're using. So we'll have to look at that file and analyze it a bit further to figure out, you know, what that signature is. But first, let's just go back, copy our file to our Windows computer, and then copy it to a directory that isn't excluded, and we get a detection again. So yeah, that definitely means, same thing, it's a sysupdate.gen file. So that definitely means that the signature is in our syscalls.h file that we're using to run the syscalls for our program. So we can take a look at that by opening up the syscalls2.h file in Sublime. And same thing we did earlier, we just go through it, commenting pieces out in order to figure out, you know, what's the signature. So to save a little bit of time, I am going to comment out the piece that I think I remember is the signature for this piece of code. And that is this bottom portion that actually defines the assembly that's needed to be executed in order for the syscalls to be used. So if I comment out this part of the code, like so, and then save this file, recompile it, and then copy it to our shared folder for our Windows host, and then open up our terminal and copy it to a directory that is not excluded in the antivirus. You'll see that we did not get an alert that time, so it did not detect our code, meaning we commented out the actual portion of the code that contains the signature for our tool. So we can now go back to our code and try to figure out what we can do in order to modify it so that the signature isn't detected anymore by the antivirus. So to do that, I'm going to uncomment the code. And because I've already done this, I do know a very easy way that this can be accomplished. So we know that something in our assembly is being detected. So the way I did this last time is I kind of just had a hunch that for every single one of these syscalls, and I didn't really know exactly which one it was, and you could try to figure that out by commenting each of them out, but then you don't even know if it's actually a single syscall. It could be multiple of them. So what I eventually did figure out is that pretty much all of them seem to be getting detected, and that's based on some signature that exists for each syscall. So what I did was, in order to change the code to make it a little bit different, I thought, okay, well, since this is assembly code and it's probably detecting some part of the assembly code as a signature, what could I do to change the code to make it a bit different? So all I did was ended up adding a NOP right before each of the syscall calls at the end of each of these syscalls. So I just added NOP and then a new line, and did that for every single function syscall that you see here. So I can just paste it in, put all these NOPs right before the syscall is actually called. And I did this for every single function because I figured, even if certain ones aren't getting detected, might as well just do it for every single function just to be safe. It's a bit monotonous, but doesn't take too much time. And my code was a lot simpler when I first did this, had less syscalls. But there you can see I added a NOP before every single syscall. So if I now save this and try to compile it again and copy it over to our share directory for our Windows host, do the same thing, copy it to a folder that's not excluded, you can see that time I did not get a detection. So that's literally all I needed to do was add this single NOP in here, and that changed the code enough that Defender could no longer detect all of these different syscalls based on their signatures. So I could even go back to my stub, uncomment the entire thing that I had commented out earlier. And now we have every part of the program that has been uncommented so that we can run it as it would function normally. And the only thing that's changed is that we added the NOPs to the portion of the program that was getting detected. So if we now recompile the file and copy it to our shared directory, go to our Windows host and copy it to the directory that isn't excluded, you can see that time it did not get detected, even though we had uncommented everything before. And we can actually run the file to see if it will execute. And it actually did. We got our calculator right here, and everything worked as expected. So there you're able to see how I used this trial and error methodology to detect the signatures that were occurring in my tool and how I modified my code to bypass them. The last thing I'm going to show for this portion of the video is a section of my C++ stub that I actually added some dummy code to, in order to help bypass some of the other antivirus signatures, for example, Kaspersky and other things than Windows Defender. So that's these couple lines right here. And you can see they pretty much do absolutely nothing. However, upon scanning my tool on sites like antiscan.me so that I could see how it stacks up against the other antivirus solutions that I don't have installed, I noticed that adding these simple 4 lines of code helped my tool bypass all of the antiviruses on the system, whereas 3 or 4 were detecting it otherwise. So it's just another way to stress how changing up the code in pretty much any way, adding some dummy code, changing how the code executes and the order in which it executes, those are all very easy and possible ways that you can make a detected tool that has signatures for it become undetected just by changing up a few things here and there. So that pretty much sums up the video. I hope you all enjoyed. Just to recap, I demonstrated how to detect signatures and then bypass them using a simple trial and error methodology. I demonstrated this in PowerShell, CSharp, and C++. Some new videos are definitely on the way, coming soon. So definitely stick around, and I'll see you some other time. Thanks.